Hi everyone, my name is Song Chonglan. I'm going to talk about the interactive reading task, transformer-based automatic item generation based on AI. My presentation is divided into 5 sections. The traditional item modeling for automatic item generation AIG is limited in scope to content areas that are relatively easy to model, such as math. The process depends on highly skilled content experts to create the models, so the AIG process is semi-automatic and costly. Modern language modeling is based on transformer architectures different from earlier neural network architectures. Because transformer architectures allow the model to leverage significantly longer contexts more effectively when making its predictions. OpenAI's GPT-3 model has demonstrated the ability to learn the format and the style of a text based on fewer than 10 examples. This is quite impressive. Next, let's see a transformer-based language model approach, the interactive reading task IR. How does IR operate? Let's take a source passage as an example. We provide to the model a set of instructions like goals, examples for use in seeding the model, and attributes to condition the final characteristics of the text output. We continue by generating questions and possible correct answers for text completion, comprehension questions, main idea, and possible title in a similar way. A different process is used for generating vocabulary in context items. The language model is used to iteratively complete each word and computes likelihoods. Ideally, successful destructors have low, but not too low likelihood and have the same syntactic part of speech as the correct answer. Human review is necessary for editorial and test design considerations. With the theory, we started large-scale pilots. This was carried out in the context of Duolingo English Test, DET. The initial machine generation phase has 2 rounds of automated filters based on GPT-3. The first round filtered the passage to be 100 to 175 words with 5 to 20 sentences. We removed the passages with repeated 8 grams, profanity, and high negative log likelihood. 800 samples out of over 14,000 passages passed this round. We retained 789 passages by generating items with sufficient destructors. Each passage and question went through a minimum of 3 content reviews and 2 fairness reviews. In summary, 454 passages were retained. The time limit for the pilot was 8 minutes, not too long, and the practice test was fully adaptive and free. The last section summarizes results from various psychometric item analysis. There is a sharp decrease in response time from the first task to later tasks. There is a wide distribution of item easiness with an overall mean score of 70%, with earlier tasks more difficult than later tasks. Most items have high discrimination proved by high item total correlation. Through a destructor analysis, we can reduce the number of items with item total correlation lower than 0.1 to only 2%. This made the analysis more accurate. If the residual correlations of local item dependency, LID, is lower than 0.3, then we can do the psychometric analysis. This means dependency between responses to any pair of items is due only to the trait being measured, not affected by other factors. Okay, here's the short summary. The IR task is a transformer-based deep language modeling approach, a combination of task design, text generation techniques, and psychometric analysis allow us to create reading passages and associated assessment tasks that can be automatically scored. The IR task has many achievements. This approach enables fully automated generation of reading material and associated questions. The authors demonstrated the feasibility of this approach for automating the creation of complex educational assessments by conducting large-scale pilot tests Unlike traditional topic modeling methods, this approach broke through the limitations of previous AIG that was only applicable to relatively simple tasks, and opening up new possibilities in the field of educational assessment. Some of the limitations of the journal include: first, AIG suffers from modeling limitations, particularly challenges in dealing with open-ended questions and automated scoring. Second, while natural language processing techniques are utilized to generate text and assessment tasks, manual review and editing is still required, increasing time and resource costs. Thanks for watching.